Okay, on this one, this is a review problem. Proton is placed 24 centimeters to the right of a rubber ball of a 5 nanocoulomb charge resting on a table. What acceleration will the proton experience? So, yeah, why don't you go ahead and do this as practice, as a review. Go ahead and pause the clip and give this a try, and when you're ready to check, you can hit play to continue. Okay, so here's our charge, and here's the proton that's placed to the right of it. And, we've got the force on that, and we have the two charges there, 5 times 10 to the negative 9th coulombs for the one charge, and then the charge of charge of a proton, the elementary charge over there. We know the distance, 0.24 meters, and so, yeah, it's going to be force to the right. So we know the force and we know the mass from our data booklet. This will be the acceleration it'll experience. All right, so let's say that we have this situation. We have 3 charges and they're based on the coordinate axis, which you should be able to draw these out, figure out what's going on. We want to figure out the electric field at 0 in the x and 0.2 meters in the y. And so, yeah, go ahead and pause the clip. Go ahead and work this through as a review. And when you're ready to check, you can hit play to continue. All right, so we've got 3, different fields here. We want to find out the field at that spot due to this charge. And, if we place a proton there, it's going to go straight down. Due to this charge, if we place a proton here, it's going to go straight left. And then for this charge, if we place a proton here, it's going to go straight up and left. And so we're going to get the, all of these for the negative 19 times 10 to the negative 9th coulomb. We've got 4,275 newtons per coulomb downward. For our bottom right charge, the field that's going to cause there is 1575, 45 degrees north and west. And for this one, 1,800 newtons per coulomb to the left. And the one that's, we're going to have to deal with is this one, right? Because this is at an angle. We're going to need to figure out the field in the x and field in the y. And so we'll break that down in the x and y, the cosine and sine. And we can get the total x, total y. For the total x, we have negative 2913.69 newtons per coulomb. And in the y, negative 3161.306 newtons per coulomb. And we can set up the x and y, the negative x, negative y, get the resultant. And Pythagorean theorem and using tangent opposite over adjacent. 4,299.2 at 47.33 degrees below the negative x-axis. All right, so let's say that we have a glass ball that's suspended in midair. The charge of the ball is positive 4 nanocoulombs. And we want to find out the strength and direction of an electric field that's needed to keep the ball suspended in air. So this is a good review one as well. Go ahead and pause the clip and give this a try. And when you're ready to check, you can hit play to continue. Okay, so here's the glass ball, 0.13 kilograms. We've got our field, and we have the force of the electric field, force of gravity, or the weight of it being counteracted. And we want to find out the strength of the field. And so if we set up our sum of the forces, those forces should balance out to the weight. And so we have that. And then we have the force due to the electric field, which is in purple here, which is the electric field times the charge. And we should get a field of 3.185 times 10 to the 8th newtons per coulomb upward to counteract the force of gravity on this object. Okay, so we have a negatively charged beach ball suspended in air above negatively charged glass sphere. And the ball is 0.75 meters above the glass sphere. And we want to figure out the charge of the beach ball to, make that happen. So let's say that we have, it's set up like this, and you want to figure out what's going on there. Now, the fact that the glass sphere is negatively charged, I don't want to confuse you there. Remember, if you have a neutral glass sphere and you apply friction, it's going to shed its electrons, right? So this glass sphere has been given extra electrons, and is suspended in the air there. So, yeah, let's see if you can figure that out. This will be a good review. So go ahead and pause the clip and give this a try. And when you're ready to check, you can hit play to continue. Okay, so the force of the charge on one due to the other is there. We have the force of gravity, so those should counteract each other. And the 136 microcoulombs will convert that to coulombs. The two forces should be, the coulomb's force and the electromagnetic force should counteract the weight. And so when we find that out, the charge that we need to be able to make this happen is 6.76 times 10 to the negative 7th coulombs. And how many electrons that is? We know, the charge, and we're trying to figure out how many there are. So we have the total amount divided by the charge of 1 will give us 4.22 times 10 to the 12th electrons. So that's the total number of electrons, to make up that amount of charge, and that's on that the ball.